Good morning, good morning, good morning. Right. So up to where we discussed in the last class, I think we just started secondary growth basic. We started basic of secondary growth, na? As I can recall. Secondary growth started. Very good. So now have a look here. We are going to discuss about secondary growth in dicot root. Where we are going to discuss secondary growth in dicot root. Where secondary growth occur? Secondary growth occur in gymnosperm and dicot. Not occur in monocot or not occur in leaf of any plant. So it occur in root and stem of dicot and gymnosperm. Is it clear? So now we are going to talk about secondary growth in dicot root. So secondary growth, during secondary growth, what happening? You just see this is a plant stem. Now what happened due to secondary growth? It become like this. It become like this. So who is increasing? Who is increasing? Girth is increasing. Thickness is increasing. Getting the idea or not? You see here, who is increasing? Girth is increasing. Girth is increasing. Diameter increase. Understanding the idea during the secondary growth process. So how this secondary growth occur, we are going to talk about. So if you talk about secondary growth, it occur in two regions in dicot stem. One is intrastellar secondary growth. Another is extrastellar secondary growth. Extrastellar secondary growth. Two types of secondary growth we are finding. One is intrastellar, another is extrastellar. So intrastellar means what? Secondary growth inside of a stele. And extrastellar secondary growth occur outside of a stele. So it occur inside of a stele and it occur outside of the stele. Getting the idea or not? So if we talk about intrastellar secondary growth, look how it occur. So I'm just drawing I'm going to deal in detail about which one first. Intrastellar secondary growth. How intrastellar secondary growth occur, I am going to tell you. Have a look here. It is epidermis. I am just making some another layer. Assume it is pericycle. It is pericycle layer. So from here inside, from pericycle to inside, up to center, it is called a stele. So now I am drawing the vascular tissue. Have a look here. This is cambium, 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 and cambium. This side, inside it is xylem, outside phloem, inside xylem, outside phloem, xylem, phloem, xylem, phloem. Are you getting the idea? So in primary plant body, this is present. So cambium is there. Which cambium is there here? Intrafascicular cambium is there. It is a primary meristem. intrafascicular cambium present between xylem and phloem. And these intrafascicular cambium is a primary meristem. So in beginning, who is there? Only primary meristem, intrafascicular cambium is there. Now you better know in center who is there? Pith is there. In center region, who is there? Pith is there. Pith or medulla is there. So here it is pith. It is in primary plant body. And now you better know this pith is radiating toward which side? Pericycle. And it is called pith rays or medullary rays. Now what happened? The medullary rays who are present between two vascular tissue and in the line of, in the adjacent to which one? Intrafascicular cambium become meristematic. Here everywhere these medullary rays is there. Everywhere these medullary rays is there. Medullary rays is there or pith there is there. It become meristematic. This area, it become meristematic. It become meristematic. So it undergoes in process of de-differentiation and going to form a cambium called interfascicular cambium. So interfascicular cambium present between two vascular bundle. Agree or not? Two vascular bundle. Since beginning, who was present? In primary plant body, who was present? Intrafascicular cambium between xylem and phloem. Now, due to de-differentiation in medullary rays, another cambium form, interfascicular cambium. It is present between two vascular tissue. Look, it is one vascular tissue, it is another vascular bundle. Between two vascular bundle, this cambium is present and which is called interfascicular cambium. So these interfascicular cambium is a which kind of meristem? Secondary meristem. And how these interfascicular cambium form? It forms due to de-differentiation in medullary rays. So the yellow color here is interfascicular cambium and green color cambium is what basically? Intrafascicular cambium. Are you getting the idea or not? Intrafascicular cambium present between xylem and phloem in same vascular bundle, and interfascicular cambium present between two vascular bundle and developed by de-differentiation in medullary rays. So both interfascicular cambium plus intrafascicular cambium, this plus this, interfascicular cambium plus intrafascicular cambium is called vascular cambium ring, together forming vascular cambium ring. Vascular cambium ring. So vascular cambium ring is formed by whom? Alternate arrangement of intrafascicular cambium and interfascicular cambium. Intrafascicular cambium is present since beginning between xylem and phloem, and interfascicular cambium developed due to differentiation, de-differentiation in medullary rays, and it is a secondary meristem. Intrafascicular cambium is a primary meristem. Both together forming which ring? Vascular cambium ring. So I hope you understand it now how the formation of vascular cambium ring occur. Tell me, understood or not? Understanding came or not ki how the vascular cambium ring formation occur? Pin your answer. Is done? Clear in the mind? So if I ask a question from all of you, please try to answer. If anyone asks a question, which kind of meristem is present in vascular cambium ring in the dicot stem? Which kind of meristem is present in vascular cambium ring in dicot stem? Then what will be your answer? Primary, secondary, or both? Pin your answer. Both primary and secondary. Well done. Intrafascicular is what? This green color, primary meristem, yellow color, secondary meristem, green color, primary meristem, intrafascicular, primary, interfascicular, secondary, intra, so primary, secondary, primary, secondary, primary, secondary, primary, secondary. Understanding came or not? Is it all right? So vascular cambium ring in dicot stem is made up of alternate arrangement of primary and secondary meristem. Understand or not? Picture came in the mind or not? So one area done or not, how the formation of vascular cambium ring occur, that picture is very clear in the mind. Now we are going to discuss how these vascular cambium ring perform the secondary growth. How these vascular cambium ring perform the secondary growth. Getting the idea or not? Is it clear in the mind? So have a look. Give your attention. So you assume here, this is vascular cambium ring, and here it is xylem. You can say xylem, primary xylem, and here it is primary phloem. Like here I am writing primary xylem, primary phloem. Primary xylem, primary phloem. Primary xylem, primary phloem. Now in vascular cambium ring, there are two type of cells are there. Two type of cells are there. I am making the dots in the vascular cambium ring through saying about a cell. So this particular cell of vascular cambium ring at these locations, getting the things, it may be present here like this. So two type of cells are there. One I told by the blue dot, one I am saying with the white layer lines. So this cell is called ray initial cell. Ray initial cell. It is present in which one? Vascular cambium ring. Another cell present in vascular cambium ring is called fusiform initial cell. Fusiform initial cell. So two type of cells. Vascular cambium ring is overall made up of two type of cells. One is what? Ray initial cell. Another is called fusiform initial cells. So fusiform initial cell, when divide, which particular cell? Fusiform initial cell, when divide toward periphery, form secondary phloem. When it divide toward periphery, it form the layer, new cell, it is secondary phloem. And when divide toward center, form secondary xylem. Are you getting the idea or not? So secondary xylem and secondary phloem is formed by which cell? Fusiform initial cell. And these fusing form initial cells show more activity toward inside. More activity toward center. Means, second, I am asking a question now. Secondary xylem will form more. Layer of secondary xylem will form more, or layer of secondary phloem will form more. Tell me. I wrote a line. So more activity toward center. Who? Fusiform initial cell. When they divide toward inside, forming new layer of secondary xylem. Getting the idea? So who is forming more? Secondary xylem is forming more, because who is showing more activity? These are showing more activity toward which one? Center side, inner side. Got the idea? Now what these ray initial is forming? These ray initial divide and form secondary medullary range. Secondary medullary range, both towards secondary xylem and secondary phloem. Secondary xylem and secondary phloem. So I am just telling you how this blue cell is dividing, that is ray initial dividing. Look here. When it is dividing in periphery, it is toward which one? Secondary phloem. This side who will form? Secondary phloem. When it will divide toward center, who will dividing toward which one? This side. So these are the what basically? These are the secondary medullary range. Are you getting the picture or not? These are dividing like this. And outside of the ring, it is towards secondary phloem. Inside of the ring, towards secondary xylem. Now see na, when it is going to divide toward this, who is forming here? Phloem. Outside phloem is forming, and towards center, new layer of xylem is forming. Understanding the idea? Is it clear in the mind or not? Clarity came? So till now I wrote something, I am telling you, then I will explain it through another diagram. In vascular cambium ring, two type of cells are there: fusiform initial cell and ray initial cell. So these fusiform initial cell, when divide toward periphery, it forms secondary phloem. When it divide toward center, it forms secondary xylem. Now this fusiform initial cells show more activity towards center, hence that is secondary xylem will produce in more amount. Secondary xylem layer will produce more. Understanding the idea? Secondary xylem layer will produce more. Is it? Now ray initial, they are dividing towards secondary phloem also. From here, it is towards secondary phloem, and it is toward which one? Secondary xylem. Getting the idea or not? And it is responsible for lateral conduction. Got the idea? This is secondary medullary range. This is forming ray initial forming secondary medullary range. Because when thickness of the plant increase, these radial conduction also required. Now earlier this is that much thick, and you think like it become like a banyan tree now. So radial conduction also required or not? So who is going to do? Who is going to do it? These are going to done by which one? Ray initial cell. Ray initial word not written in NCERT, but they have given secondary medullary range is forming. So if you don't know ray initial, how will understand about secondary medullary range? Understanding the idea? Picture came or not? Now I am going to tell you ahead how they are dividing. Look here. Look it through a diagram. Suppose that here I am just drawing vascular cambium ring. I am just making it somehow bigger. Okay, ji? So here, after some time it become like this. Earlier this is the thickness. Earlier this is the thickness of the vascular cambium inner ring. Now it is like this. It is primary xylem, primary phloem. When secondary growth occur, what happen? It is going to divide like this. So many layer form. Now who was primary xylem is come in the center, and who was primary phloem? Who was primary phloem is come in periphery. You just understand with this diagram, it will give you a better picture. It is primary phloem, it is cambium, part of cambium ring, and it is primary xylem. This is the thickness. Now secondary growth occur. It become like this. This is cambium. New layer toward inside. Who will form? Secondary xylem. Toward this side, who will form? Secondary phloem. So primary phloem, so it is cutting this side and forming secondary phloem. So who will push outward? Here it is primary phloem, it is secondary phloem first layer, secondary phloem second layer, secondary phloem third layer, secondary phloem fourth layer, secondary phloem fifth layer. Now new xylem is forming. So as new xylem will form, protoxylem move towards center na. So here it is protoxylem, here it primary xylem, you can say here secondary xylem first layer, secondary xylem second layer, secondary xylem third layer, secondary xylem fourth layer, secondary xylem fifth layer, secondary xylem sixth layer. So here I wrote the number of layer more. So it is showing more activity toward which one? Inside. Showing less activity toward which one? Outside. So who is forming more? Secondary xylem forming more. Now either you understood or not understood, for that I am asking a question. So can I say it that when new layer forming, distance between primary xylem and primary phloem is increasing. As new layer of xylem and phloem form due to activity of the cambium, distance between who increase? Primary xylem and secondary xylem increase. Agree or not? Who is toward the cambium? Oldest secondary xylem or newest secondary xylem layer? Near the cambium, which layer is there? Oldest secondary xylem or newest secondary xylem? Newest secondary xylem. Older one going to push away and newer one is just present near the which one? Cambium. So who is the newest here? Secondary xylem 6. Getting the idea or not? Is it clear in the mind? And who is the oldest here? Primary xylem. So when new layer is forming, who is pushing toward center? Xylem is pushing toward center, and who is pushing toward periphery? Phloem is pushing toward periphery. Are you getting the idea or not? Getting the idea? So now I am writing a conclusion of it. So what is the conclusion? Due to activity in the sense division here in vascular cambium ring, primary xylem pushing toward center, and it remain more or less intact in center. Intact in center. It remain more or less intact in center, and primary and phloem push toward periphery. Who is pushing toward center? Xylem. And who is pushing toward periphery? Phloem. Due to more activity toward inside, toward center, pressure exerted in outside, more activity, more growth toward inside, pressure exerted on outside, it result in, and due to that primary and secondary phloem gradually crushed. Gradually crushed. Gradually crushed. Now have a look. What I told here in that long paragraph, I am just explaining it. I told here, look here, this is the, when it is dividing, vascular cambium ring, dividing toward inside. When it is dividing toward inside, many layer of who will form? New xylem form. These are the layer of who is forming? Xylem is forming. These are the layer of xylem is forming. And toward outside, who is forming? Layer of phloem is forming. Layer of phloem is forming. Layer of phloem is forming. Whose layer formed more? Xylem. Here it is which one? Cambium. I am making another prominent color. Here it is vascular cambium. So cambium showing more activity toward inside, more layer of xylem formed toward center, less layer of phloem formed toward periphery. So growth occur more toward inside. So when growth occur toward inside, it exert pressure on which side? Outside. Growth occur, opposite direction pressure occur. And impact of the pressure is what? Layer of phloem crush gradually. Suppose that it is primary phloem. It is secondary phloem 1. It is secondary phloem 2. So who is going to crush gradually? First this will crush, then this will crush, then this will crush. As many layer of xylem form, impact is what? Who is crushing? Phloem layer is crushing. Understanding the idea or not? Picture came or not? And who remain intact in the center? Xylem remain more or less intact in the center. When you read NCERT, you got this line. Who are growing toward inside is intact. Why intact? Because growth when occur toward inside more, it exert pressure in opposite side. So impact of pressure is exerted on which one? Phloem. And who is getting crushed? Phloem is getting crushed. Who is not getting crushed? Xylem is not getting crushed. So during secondary growth, who is crushing? Primary and secondary phloem crushed gradually. NCERT wrote that line or not, and that picture came or not. So look now, thickening is increasing or not increasing. Earlier, who was there? Earlier it is cambium, and here it is primary phloem, and here it is primary xylem was there. Earlier this is the level of thickness. Now you look the level of thickness. It is increasing or not increasing? Tell me, increasing or not increasing? Increasing, na? So this is what basically it become like this. Who occur? Secondary growth occur or not? Diameter increase or not increase? Clear came, picture came or not came in the mind? So how the intrastellar secondary growth occur? A picture came, clarity came in the mind or not? Tell me about the intrastellar secondary growth. Clarity is there in the mind or not? Is it done? Understood about the intrastellar secondary growth? So what I told, vascular cambium ring show more activity toward inside, forming more layer of xylem, less activity toward outside. So peripheral, who is pushing? Phloem. Center toward, who is pushing? Xylem. Xylem growth is more toward inside now, so pressure exert toward outside. So who will crush? Who will crush? Phloem will crush. Understanding came or not? Now I am going to tell you about annual ring. Annual ring. So what is annual ring? So what's happened? In temperate region, temperate area, plant growth is not uniform throughout the year. Not uniform throughout the year. Understanding the idea or not? So in a spring season, plant showing more activity and in autumn season, plant showing less activity, means less division. Got the idea? So because these problem not a problem of which area? Tropical region. So in tropical region, you will find whole year it is showing almost same kind of activity. So what's happening in spring season? In a spring season, you will find cell will divide more and or cell in the sense cambium show more activity. Where to write what? Cambium show more activity means division. More activity. Getting the things or not? And it form large size xylem vessels. Large size in the sense of diameter. Here large diameter. Getting the things or not? Form large size xylem vessels. So I am writing size here in the sense of which one? Diameter. And in autumn season, cambium show less activity and diameter of xylem vessel is small. So xylem vessels, you know, it is a pipe-like structure, cylindrical structure, tubular structure. So wider tube is formed in which season? Spring season. And narrower tube forming which season? Autumn season. Understanding the idea or not? Picture came in the mind or not? And these are due to seasonal variation because plant growth depend on some external factor and some physiological factor. So activity of the cell not all the time uniform. Some factor is controlling it. So who is not a good season for the plant growth? Autumn. And who is a good season for the plant growth? Spring. So in spring season, cambium showing more better activity. Getting the idea or not? And in autumn season, these cambium showing less activity. Is it clear in the mind? And due to non-uniform activity in various season, what we found, I am telling you. Look here. So what we are finding? We are finding such kind of condition. So these are, when you cut the transverse section of a stem, and especially that who are growing in which season? Temperate season, you find such ring like a structure are present. You find such ring like a structure are present. So this is thick, it is dark ring. And this is which one? Thin ring. And this is light ring, light color. I just want to give it brownish color, so but that color combination not matching. Light color ring, and it is thick ring. Got the idea or not? So these dark color ring is formed in autumn season. Dark color ring form in autumn season, but this is thin ring, less activity is there in autumn season. And light color ring formed in a spring season, and that is the reason more activity is there, so this is a thick ring, but it is light color ring. Color is light, but thickness is more. So who are forming in, because you better know, these are the ring present in which one? Secondary xylem. These are the ring present in which one? Secondary xylem. These ring formation occur due to activity of cambium. Understanding the idea or not? So that is the reason who are forming in autumn season is called autumn wood, and who are forming in spring season is called spring wood, because these all are secondary xylem. A spring wood. Understanding the idea or not? A spring season is also called early season, and autumn season is also called late season. Got the idea? So if we talk about these dark ring have more density, and these light ring have less density. Got the idea? So in 1 year, in temperate climatic condition, two ring form. One light ring, light means a spring wood, getting the idea, and one dark ring, Getting the things or not? That is called which one? Autumn wood. Both together is called annual ring. Both together is called which one? Annual ring. So, in 1 year, 2 ring we are finding. One light, one dark, 2 ring is there. Is it clear in the mind? So, B can determine the age of plant by counting the annual ring. Got the idea? And it is called dendrochronology. We can determine the age of plant by counting the annual ring. It is called dendrochronology. Now I am asking a question. A plant have 100 light ring, 100 dark ring. What is the age of plant? 100 light ring, 100 dark ring. Tell me, 100 light ring, 100 dark ring. What is the age of plant? How many year? How many year is the age of plant? 100 year. Very good. Now, I am writing which one? Springwood and autumn wood. Wood means secondary xylem. Wood means secondary xylem. Secondary xylem form in a spring season. It is also called early wood. It is also called late wood. It is what? Thick band. It is thin band. It is light color band or ring. It is dark color band. Dark color band or ring, you can say. Band oblique ring I am writing, so you not get confused. It is less density and here it is more density. Vessels have more diameter, here less diameter. Got the idea or not? So these are the some of the difference between a spring wood and autumn wood. And these spring wood and autumn wood together forming which one? Annual ring in temperate climatic condition. In tropical area, a stem, annual ring is not prominent. Not prominent. Even in root, annual ring is not prominent. Because root grow in soil and in soil seasonal activity not occur. Plant grow in coastal area, annual ring is not prominent. Plant growing in coastal area, because coastal area season are same, so no seasonal changes occur. Annual ring not prominent. Ring formation due to occur due to which one? Unequal activity. Understand the idea or not? So who is over? Spring wood, autumn wood is over. Now we are going to deal one more thing, that is which one? Heartwood and sapwood. Heartwood and sapwood. heartwood and sapwood. So when you cut a TS of plant, you find such kind of thing. I am telling you through the diagram. This is ring I am showing, and you will find central part is dark brown. When you cut the TS of a stem, you are finding central part is dark brown and peripheral part is light brown. Getting the idea or not? So these peripheral, it is which one? Sapwood, who are light brown, and central part here is what basically heartwood. So how these heartwood and sapwood differ? So heartwood and sapwood differences I am writing, you will got a better picture. So present in periphery, sapwood present in periphery. You look in the diagram also. It is centrally located, present in center. So it is light brown, sapwood is light brown color, wood, and it is dark brown color. Hardwood is dark brown color. If you swipe wood, it is living. It is dead. No component of xylem is living in case of hardwood. You can say it perform conduction of water and mineral. Here it is provide only mechanical support. Mechanical support. Now you can ask why it is light brown and why it is dark brown. So in hardwood, what is there? Deposition of resin, tannin, gums, essential oil, and other aromatic substances occur. Aromatic substances occur. Deposition of which one? Resin, tannin, gums, essential oil, and other aromatic substances occur. So you just try to understand. Now I am telling you this is a pipe and this is another pipe. This pipe is blocked due to deposition of something. So when this pipe get blocked, it become a rod, na? Who is depositing in this pipe? In hardwood, resin, tannin, gums, essential oil. So both tracked vessels are what basically blocked. And when a pipe get blocked with something, means it is not no more empty, so it become more denser, na? And due to that reason it become which one? Dark brown due to deposition of this. So these resin, tannin, essential oil, and aromatic substances not deposited. So these all pipe is blocked in hardwood. not deposited. So sap would not repel the termite, an insect. Termite and insect. Who repel? Repel termite and insect. Because these chemicals act as a termite repellent. Less density present in heartwood. Sorry, sapwood. Less density present in sapwood, more density present in heartwood. If you talk about sapwood, not good for furniture making. But heartwood good for furniture making. So the costly furniture came when you purchase the furniture of sapwood. Sorry, heartwood. When you purchase the furniture of heartwood. Sapwood furniture, when you purchase from the market, powder came from that furniture. Powder came from that furniture. So that is not a good furniture. So you got the difference between heartwood and sapwood or not? So here I told you some differences between heartwood and sapwood. Once I am revising it and then we will finish the class. So look here. I told sapwood present in periphery, heartwood centrally located, light brown color of sapwood, dark brown color of heartwood. It is living, it is dead. Why it is dead? Because who is blocked? Every component is blocked due to deposition of the secondary matter. So sapwood perform conduction of water and mineral. Heartwood perform which one? Mechanical support. Resin, tannin, essential oil, these are not deposited in sapwood, these are deposited in heartwood, and due to that reason, its density increase. It not repel the termite, heartwood repel the termite, sapwood have less density, heartwood have more density. It is not good for furniture making, it is good for furniture making. Now I am asking a question. When plant become older and older, which wood will increase? Heartwood will increase or sapwood will increase? When age of the plant grow more, amount of heartwood will increase or sapwood will increase? Answer that question. Heartwood will increase. With age of the plant, when plant become more diameter, whose proposition will increase? Heartwood. Getting the idea? Clarity came in the mind. Sapwood present in few peripheral layer. Slowly, heartwood become more wider. Got the idea? Is it clear in the mind? So spring wood and early wood is different. Heartwood and sapwood is different. I told about the both. You understand it? So thank you very much. So remaining part we will deal in which class? Next class. Heartwood, sapwood is over. So extrastellar secondary growth and secondary growth in root is remaining. After that, this next class, this chapter will finish and probably we will start the new chapter. Okay, ji? Thank you very much. Bye-bye. Have a good day to all of you. So you understand it or not? Tell me very honestly. Intrastellar secondary growth, how it occurs, you understand? Is it clear? Okay, ji. Bye.